In this video, we will talk about 3.3, determining empirical formulas. Remember from chapter 2, we learned that an empirical formula is the simplest whole number ratio of a molecular formula, which is the actual chemical formula of the molecule. In this chapter, we will learn how to find the empirical formula without being given the molecular formula, but just given some sample data. So in this problem, it says a sample contains 5.31 grams of chlorine and 8.40 grams of oxygen. Find the empirical formula. The subscripts for a formula must always be whole numbers, since we can't have a partial or a fraction of an atom. The ratio of subscripts can be in moles because we know that a mole is an exact count of atoms. So, first step is to convert these masses to moles. So let's go to the periodic table, and we can see from our mole map that we're given mass and we want to get to moles. So we're going to use the molar mass. We are not going to use Avogadro's number. In the problem, we have chlorine and oxygen. So we are going to use this mass for chlorine and this mass for oxygen. So we need to convert 5.31 grams of chlorine to moles of chlorine. Molar mass has units of grams per mole. The mass, 35.45 grams of chlorine, must go on bottom so that we can cancel grams. And we put the moles, the 1 mole, on top. If you pull out your calculator, we can solve this value. And then for oxygen, we have 8.40 grams of oxygen divided by 16.00, which is the molar mass of oxygen, and we're going to put the 1 mole of oxygen on top. This comes out to 0.15 and this 0.525. These are the amount of moles that we have. So technically, this is our subscripts. We've got chlorine 0.15 and we have oxygen 0.525. Of course, we can't have these decimal numbers as our subscripts because we can't have a partial or fraction of an atom. So mathematically, we're going to try to turn this into a whole number ratio. If we divide both of these values by the smaller of the two, the 0.15, we see that this comes out to a 1 for the chlorine, and for the oxygen we get 3.5. So this is closer to whole numbers, but now let's just double both of them because a ratio of 1 to 3.5 is the same as a ratio of 2 to 7. So now we can see that our subscripts for the empirical formula is Cl2O7. And here are all of the steps spelled out. First, we need to convert from mass to moles for both of the elements. And then we're going to divide that mole amount by the smallest of the two of them. And then we need to turn our numbers here into whole numbers. So we have our subscripts 2 to 7. Let's try this next example. Pause the video and try to solve this before looking at the answer. First step, we need to convert both of the masses into moles, and then we're going to divide by the smallest. So we are going to divide both of these values by the 0.626, and we come out to 1 to 1.5. If you double both of those, we come up with our answer of Fe2O3. Here are the 3 steps to finding the empirical formula of a molecule. Number 1, find the number of moles of each element from its mass using molar mass. Then divide each element's molar amount by the smallest molar amount to get your subscripts. And then if it's not whole numbers yet, then you're going to have to multiply your subscripts by either 2 or 3, some small integer, in order to get our subscripts into whole numbers. Let's try another example. Work this problem out before going on to see the answer. First step, as always, we're going to convert both of the masses to moles using the molar mass of each element. just to remember that this number here is the average atomic mass on the periodic table for arsenic, and this 16 is the average atomic mass for oxygen on the periodic table. Then we need to divide both of the mole amounts by the smaller of the two, which is 0.04351. And then we see we come out with 1 to 1.49, which easily rounds to 1.5. And then our subscripts must be doubled so that we have whole numbers, AS2O3. This is the first problem on problem set 3.3. In this problem, we are given percents instead of masses. Remember from our 3.2 lesson on percent composition that the percent composition of any compound is constant regardless of how big your sample size is. So whether we have 13.4 gram sample or 100 gram sample or a 3,780 gram sample, we will always have 80% of carbon and 20% of hydrogen for this particular substance. So let's assume that we have a 100 gram sample because then we know we would have 80 grams of carbon and 20 grams of hydrogen. Now we can solve for the empirical formula of this compound by following the same 3 steps we have just learned. First, convert both of the masses to moles using the molar masses of each of the elements. And then we're going to divide both of the mole amounts by the smaller of the two, which happens to be the carbon mole value. And then we can see that we come out to a ratio of 1 to 2.98. 2.98 is close enough to 3 that we can just round. And so then the empirical formula is CH3. So now you can complete problems 1 through 10 on problem set 3.3.